Okay. Lesson 11.3 is all about dividing polynomials. So we're going to delve into just the dividing. And then you and I kind of talked, we're going to do the top two, and we'll save the other two for Monday. The top two, what's the difference between the top two and the bottom two?
The top two, it's just dividing by one.
Right. The top two is just dividing by one term, which makes a big difference of how you can work that problem. Because we're just dividing by one term, it makes it much easier. When we get down here to divide about two terms, that won't be quite so easy. Okay? So, in terms of, so we have the trinomial 4a cubed plus 10a squared plus 3a divided by 2a squared. The idea here is since we're just dividing by one term, basically what we're going to do is we're going to take each of these terms and divide it by 2a squared. So we're going to divide the first term by 2a squared. We're going to divide the second term by 2a squared, and we're going to divide the third term by 2a squared. And at this point, because we're just dividing by a monomial, so just by one term, we just divide those, simplify, and we're done. Okay, so 4a cubed divided by 2a squared. 2a, because 4 divided by 2 is 2. Subtract your exponents, a to the first, or a. I'm going to carry my plus sign down. 10a squared divided by 2a squared. 5. 10 divided by 2 is 5. A squareds cancel out. 3a divided by 2a squared. Good answer. Okay, so I was just checking. Okay, I do usually leave it as a fraction. Okay, so as we leave this as a fraction, well, first of all, 3 divided by 2, I mean, it's 1.5, it's 1.5, but I'm just going to say 3 over 2 for the number part. Okay, we're going to leave it as a fraction. Now, in terms of a divided by a squared, I mean, yes, you could subtract, and that'd be a to the negative 1. But we don't use, there's sometimes you're just not allowed to leave a negative exponent. And so if we don't want to leave a negative exponent, there's 1a on top, 2 a's on bottom. We can cancel out one of those a's, and then what's that leave?
An a with 2.
An a on bottom with the 2. And so what I would write this as is 3 over 2a. So 2a plus 5 plus 3 over 2a, and you're done there. Okay? So the fractions may be a little different, but it's just a matter of cleaning it up, simplifying it the best we can. Okay, let's do our second example. 5b to the fourth minus 15b squared plus 1 divided by 5b cubed. Okay, divide all the pieces by 5b cubed. Okay, and that's because, again, we're dividing by a monomial, by one term. 5b to the fourth divided by 5b cubed. B. 5 divided by 5 is 1. B to the fourth divided by b to the third. We got 1 left. Minus this time. 15b squared divided by 5b.
Well, it would be 3, but I don't know.
Okay, so 15 divided by 5 is 3. So depending on what happens here, we can think of 3, or if we have to put it in a fraction, that's 3 over 1. Okay, because, you know, it's like dividing both of these by 5. Now, b's. So if we talk about b's for a moment, how many b's can we cancel? We can cancel 2 b's. Where's the leftover b at? At the bottom. And so what I'm actually going to write, 15 divided by 5 is 3. 3 over 1. So I'm going to put the 3 on top, and then I'm going to put the b on bottom. And you could have 3 over 1b, but you know the 1 is unnecessary. So I'm just going to put 3 over b. So yeah, so 15 divided by 3 5 is 3. 15 was on top, bigger number, so bigger number on top. B squared divided by B cubed. One more B on bottom, so the B goes on bottom. Plus 1 divided by 5B cubed.
Just leave it as a fraction.
Leave it as a fraction. 1 doesn't divide by 5, I mean that's 1/5. There's only B's on bottom, so 1 divided by 5B cubed. And there shouldn't usually be any cleanup after that, like any like terms to add or subtract, because unless there were like terms up here in the original problem that weren't already added or subtracted, there's not going to be like terms down here. Okay? I guess we probably could have done this all in one day, but I also have to play catch up with Jacob then, so.
Yeah.
The difference on the bottom is because we're dividing by 2 terms, we end up having to do long division.
Oh god. I don't even actually remember how to do long division.
Well,
That's something I found out recently.
okay, so we'll review how to do long. And honestly, remind me if I forget. One of the things I often do anytime I teach long division of like polynomials like this is I go back and grab just like a 1,248 divided by 35. And we actually do that in long division to try and review the process of how we do that without a calculator before we jump into this. So long division for Monday sound like a good plan then, I'm guessing?
Yeah.
You don't want to do, now that I said long division, you really don't want to do that today, do you? So.
I remember hating it.
Okay, so we'll come back, talk about these on Monday. Hopefully Jacob will be here to join us and go from there.
Maybe, yeah.
At home. So, okay.